Good evening, everyone. Wow, what a crowd. Thank you all for coming on a Friday evening. I have two favors to ask. First, we have a number of UT students in the room. This is going to be on the back bar, okay? So after the talk is completed, I ask that all of the UT students who are here to please sign this for Dr. Ocampo, okay? The second favor is take this out and turn it off, please. Thank you. So let's get started. Good evening. This is our 16th annual 2016 MOSI National Hispanic Scientist of the Year. And Dr. Adriana Ocampo is our recipient of this year's award. We are so pleased and thrilled to have her here today. I could read you her very long resume, but I would prefer not to do that. I would rather prefer for everybody in the room tell you what this is about. And hopefully when you learn what this is about, that you leave here, no matter what your age is, and decide to engage with the young people in our community and society and in the world, because it makes such a tremendous difference. So the genesis of this event is from my friend, Mirchi Azran Blanco. Mirchi, where are you? Raise your hand, please. There she is, okay? We met in 2001, more on this when we have dinner tonight, at the end of the dinner. But her idea was to bring role models in, top-notch role models, to meet kids, to spend a day at MOSI, the Museum of Science and Industry, and interact with children, and give them a chance literally to be rock stars. We're used to people who play for rock concerts or athletes to being rock stars, but it's time scientists got their due, and it was Marucci's idea to give them their due and recognize that scientists too are rock stars. Now, what is coveted of rock stars and athletes by kids and adults alike? Getting to know them, right? Well, this event gives them that opportunity. Getting an autograph, right? So let me show you a little bit of what happened this morning at MOSI. And I'll be very brief. So early in the morning, this was about 9:30 in the morning, 1,300 middle school and high school kids came to campus, mostly middle school kids and largely economically disadvantaged kids. Many kids whose parents never went to college, all right? And parents, teachers, the like. This was one parent, I believe, or chaperone who was there, and she was thrilled to be hearing about what a NASA Planetary Geologist does. And so she wore her shirt that you all can read. And if you can't see what it says down here, it says, "You guys have no life." So during the course of the day, the kids get to go around, cavort around MOSI, and have a great time, play with the exhibits, enjoy a day in a science museum, and most importantly, in subsets of about a couple hundred kids, get together, sit in a room, and hear an inspirational talk by our scientist. We do this every year. But here's the really crazy thing about all of this. We give them backpacks, and then at the end of the talk, we make sure that there's plenty of time if the kids want to go up and meet the scientists and get an autograph, they do so. So these kids this morning, these were high school students who were in the first group, and at the end of her presentation, you would have sworn you were at a rock concert, the way the kids were excited and clapping and even whistling to congratulate Dr. Ocampo for her presentation. And then they lined up. And I don't know how she got through this. Look at the kids. They don't have to do this. This is their choice. They want our scientist to leave them a memento to remember this day. And our scientist takes the time to meet individually with these kids one-on-one for at least a minute or two and autograph their backpack. Ask Marucci about the story of one kid when we used to give a shirt, if you have time today, and what the autograph meant to that kid a number of years ago. So Dr. Ocampo's had a very long day, and it's almost over. She's going to give this one presentation. Okay? The rest of us have been doing what we need to do to get ready for today. And for me, that included driving back to campus to set things up here, also going downtown to pick up the proclamation from the mayor. And when I was driving downtown, how wild is this? We've got a NASA Planetary Geologist. Her work is on the effect of an impact crater in the Yucatan Peninsula, its discovery, and what it meant for the extinction of the dinosaurs. And that's largely what she's going to talk about today. And I'm at a stoplight in downtown Tampa, and I've never seen this before. How random is that? Okay? So at the end of this, I have a couple of requests. First, the adults in the room. If you ask a question, and I'm sure many adults are going to be eager to ask questions, the kids in the room will likely go quiet because they'll be afraid to ask their question because they might fear that they can't say something or ask a question that would match what you're going to ask. So here's the rule when it comes to asking questions, which I moderate at the end. Kids, you get to go first. Okay? If an adult raises your hand, I don't care if you're Horseshack, and if you're old enough to know Welcome Back, Kotter, you know what I mean. I ain't calling on you. All right? The kids go first when it comes to asking questions. Afterwards, I want to ask all of the kids. There are a lot of college students here who'd love to meet you. I know I have a number of my students here. They're great kids. If you want to talk to some college students and they're freshmen, I've also got some sophomores, juniors, and seniors here. Okay? By all means, talk to them. They're super nice people. Ask them what college is like. When we sit down and have dinner, a number of them are going to be in there with us. I put you guys in the middle of the room. You're surrounded by friends, okay? So please, don't be afraid. Talk to people, okay? Enjoy this evening. This really is for you. At the end of this, there'll be a chance for you to take a picture with Dr. Ocampo, talk with her for a minute, because we'll spend about 20 minutes in here, and then we'll move over to the reception and then dinner. But I also want to recognize and acknowledge a friend who's here as well, Dr. Niels Diaz. Niels, would you raise your hand, please, so everybody knows where you are? So you have, and Marucci, it blew my mind when I thought about this a short time ago. I have been doing this for almost half of my adult life. That's how long it's been. So I hope I remember the year correctly, Niels. Our 2009 MOSI Hispanic Scientist of the Year. So you've got a nuclear engineer and physicist in the room who was the former chairman of the U.S. Nuclear Regulatory Commission. He was involved in the development of radiation propulsion systems for NASA, which is pretty darn cool. And in fact, that was so cool, that did not go unnoticed. Who knows who this is? This is one of my students' socks the other day. She knows I'm a hardcore Trekkie. Who is that? Live long and prosper, right? Okay. You folks are in the presence of the only living human being who is referenced in any Star Trek episode, original series, Next Generation, Deep Space Nine, Voyager, and movies. In the episode Memory Alpha, Dr. Niels's warp field theories are referenced by Data and Geordi when they're talking about tinkering with the warp drive in the USS Enterprise. Okay? So by all means, you have Dr. Ocampo here. You also have Dr. Niels here. You have two outstanding scientists in the room, and they're happy to spend time with you. So, without further ado, to speak about cosmic collisions and dinosaurs, let me see how I get rid of this. Get this ready for her. Please welcome Dr. Adriana Ocampo.
Well, it's really a pleasure to be here with all of you this evening. It's my first visit to your incredible university. And it looks like Wonderland here. So, but I wanted to spend just a couple of minutes. Well, I should say so introduce myself. I'm Adriana Ocampo, and I was born in Barranquilla in Colombia. I grew up in Argentina, in Buenos Aires, and then my parents emigrated here to the United States, and I was fortunate enough that helped crystallize my dreams of becoming a rocket scientist or space scientist, as you may want to call it. But I want to get to know you a little bit more. Tell me, just raise your hands. I understand there are some high school students here. I'd like to recognize them. Excellent, bravo. I know you're here for very special reasons because you excel in your areas. I'm very happy to see a lot of young ladies among the group. And let's see, undergraduates. Excellent, bravo. Graduate students? Good, hello. There. And professors, staff, researchers? Excellent, thank you. Well, thank you for joining us. Thank you for allowing me to get to know you a little bit better. One final question. How many of you speak more than one language? Okay, not bad, not bad. Good, good. You know, I've been telling the kids this morning the importance of speaking more than one language. No matter in what field you are, our planet is getting smaller and smaller. And it's so important to get to know all the wonderful people living in this unique place that we call Earth. And having that extra tool of having another language to communicate is a tremendous asset. And for those, especially here in the audience, that are starting their careers and planning it, I would highly, highly encourage that you take some time to learn another language, no matter what that is. And hopefully you don't stop at 2, but maybe 3 or 4. It truly is a tremendous asset. So with that, I wanted to share a little bit. You know, I've been very fortunate being able to realize my dreams. At the beginning, you would say that the odds were against me. I was a little girl growing up in a developing country where space was really truly a foreign word, non-existent. And I had to face, and at that time I only knew one language, my native tongue, which is Spanish. So it really was a challenge to overcome a lot of the challenges that I had to face, apart from the redundancy. But I really was inspired by my parents. My parents were my heroes. They really gave me the opportunities to flourish. Neither of them were able to complete, basically, they didn't have the opportunities to go to college. So my sisters and I were the first ones to have that opportunity. But they knew that education was the vehicle to realizing your dreams. So that they installed on us, that was the biggest legacy they knew they could leave us, more than anything else. And it's an honor to them that I can stand today here and be able to share a little bit of the wonders of space exploration, and as well of the incredible voyage that it is science and research that really inspired me to continue in this career as a planetary scientist. And with that, I wanted to start a little bit by sharing a brief movie, which is a little bit the story of these missions, which I grew up with. I was able to I started volunteering at the Jet Propulsion Laboratory in Pasadena, California. I don't know how many of you have heard of JPL, but is the Center of Excellence for NASA on the exploration of the solar system. So to me, that was Disneyland. I couldn't believe my great fortune, and I volunteered. They allowed me and indulged me, and finally they couldn't get rid of me, so they decided to give me a job as a technical aide. So you could say I started truly from the bottom up. I worked my way through school, and I'm currently then leading the New Frontiers program, which is a program that has 3 missions One is the mission to Pluto, which we'll talk briefly about. The second one is the mission to Jupiter that is called Juno, and is currently orbiting around Jupiter. It's the first time we have gone to the largest planet in our solar system with solar panels. So it truly was a mission with a lot of innovation and energy benefits that have helped us here on our planet as well. And finally, on September 8th, we launched a mission called OSIRIS-REx. Anybody heard of OSIRIS-REx? Okay, so OSIRIS-REx is an amazing mission, and you will hear more about it, I'm sure, in the years to come. This is the first time that the United States is going to go to an asteroid, extract a sample of asteroid Bennu, and return it to Earth in the year 2023. Japanese tried to do something like this earlier with another asteroid, and they were partially successful. Space is hard. It really is. If you want a challenge and a profession that takes you to the limit, and where you do things that no one has ever done in the world, go to do space exploration, because it will challenge you. There is no question about it. As you probably heard, unfortunately, the European Space Agency just recently, October 19th, actually, I was just in Russia and came back, and they were all excited with high expectations. We were hoping for the best. It was a collaboration between ESA and Roscosmos, which is the Russian Space Agency, and unfortunately, their lander, Schiaparelli, crashed. And it's a loss for all of us. It's a loss for our planet. And going to Mars, going to any planet to insert a spacecraft, a robotic spacecraft around it, going to land, to extract a sample, it truly, truly limits the the limits of our capabilities. But we learn, and that's a key lesson that we have to remember. There is no such thing as failures. We have anomalies. From any and every anomaly, we gather lessons learned, how to do it better the next time. And I think that's a technique that I have learned from NASA, and it has served me well in all phases of life. There is no use on blaming. The only positive and beneficial thing to do is to go learn how to do it better. And in that process, learn how to work as a team. Working as a team is a tremendous, tremendous asset. What I'm going to share with you this evening, it would not have been possible if teamwork was not there. I could be very well, overseeing, managing this program, but I'm just an enabler. Is the teams of scientists and engineers that really allow us to get this information, that incredible knowledge database that we are so fortunate. And this country is an exceptional place for space exploration. It's a country in the world that invests the most in space. And because of that, we have amazing things like this. So where were you July 14th, 2015? Did you get a glimpse of Pluto? So I'm happy to report the spacecraft is working exceptionally well. We have gathered all the information and met more than the level 1 requirements, the scientific levels that are required to be able to say that the mission was a success. And the data is still coming down. It will complete its downlink at the end of this month, the New Horizons spacecraft. It continues its journey to another Kuiper Belt object, which is called MU69, and you all have a date with New Horizons, July 1st, 2019. That's where we will encounter this new world. And I hope you join us in that next adventure. It's going to be extraordinary. It's a type of body we never seen before. We really are not have any idea very much. I mean, we're having some observations that we will be doing using the Hubble Space Telescope, as well as the large ground-based telescopes here on Earth during special occultations that are going to be taking place during the summer of July 2017. And we hope to determine a little bit more about its size, its mass, its rotational period. We're truly going to the unknown here. We knew a little bit more about Pluto before we flew, and we have to keep in mind that this was a mission. New Horizons was launched in January of 2016, 2006, and it arrived 9.5 years later on July 14th, 2015. It takes a long, long time to get there, and it was really one of the fastest spacecraft that human beings have built. The fastest now, I always say I have the Maseratis of the solar system in my program because both Juno, the mission to Jupiter, won the prize in the Guinness Book of Records as the fastest spacecraft humans being ever made. And yet it took 5 years to get to Jupiter still. So the exploration of deep space is a tremendous challenge. The exploration of space overall is an incredible feat. And I think we are all very fortunate, and especially you, the young folks among us, that you're living in extraordinary times. Just think, for the first time in human history, we have seen all the major planets and minor planets in our solar system. Basically, we have been able to go out to the last outpost of the solar system. And just as a curiosity, let me ask you, how many planets do we have in our solar system? Okay, I hear 9, I hear 8. 8. Well, yeah, the big controversy started with the International Astronomical Union when it declared Pluto from a minor planet, since Pluto did one of the qualifications. It had to be able, as it orbited around the sun, to basically clear its path from dust, from debris. And Pluto was not quite able to meet that specification, and that's why it was downgraded to a minor planet. So here you go. But the ironic thing is that now, thanks to the mission that it was sent to Pluto, New Horizons, now we know our solar system is extraordinary. It's a lot more rich. It has 8 major planets and thousands of minor planets. So next time you are asked that question, now you know. It's like New Horizons provided us with a new set of glasses, and we finally are getting to really the true structure of the solar system. So it's a great adventure, and I hope you are part of it. I hope your careers take you to it. I hope you feel challenged, because space is an extraordinary place to be, and we are in space. As it's been said, we're all astronauts, and our spaceship is planet Earth. we live in space and we have to learn from it. So with that, I wanted to now take you to another phase of research that I was very fortunate to be part of, and it's a tale of the scientific process of how incredible science can be. And I wanted to then invite you to really take a journey with me that will take, well, basically I want to invite you to come on a ride with me on this virtual spacecraft. And our virtual spacecraft is truly very special because not only it let us travel through space, but it also will let us travel through time, as you will see. And I hope at the end you'll get perhaps some ideas on how our solar system formed, and perhaps also answer the questions of what happened to the dinosaurs. So this is the story of cosmic collisions and dinosaurs. And the rectangle you see is our virtual spacecraft window. And our journey, as you know, I couldn't help it with. Our journey begins in a galaxy far, far away, very long, long time ago, 4.5 billion years, as a matter of fact, when our beautiful Milky Way was forming. And as you know, the Milky Ways and the majority of the galaxies have black holes in its center. So we were very fortunate that our solar system formed at the edge of one of the outer portions of the Milky Way. So here we have the graphic, the artist's depiction of that dust that resulted from the explosion of stars that were the source of all the heavy minerals that compose our planet, our bodies. So we truly are stardust. We're able to see a very young solar system with a sun, with a star that is just starting to be formed. And out of those incredible explosions, stellar explosions, this material started to aggregate. It was what we all know as the fragments of planets, and it was these embryonic planets that started forming during this process. As you can see, our solar system is very young. There are no planets orbiting around the young sun, but the collisions that started to take place is how we believe these embryonic protoplanets started to form and eventually gained enough mass and started orbiting around our sun. The energy emitted by these collisions, by these impacts, helped to agglutinate the material one to another, and eventually enough energy and heat was imparted to make that these embryonic planets would be able to differentiate in different layers and precipitate and contain a nucleus if enough mass was accumulated. And this is what happened to our planet Earth. As you can see, there's still no oceans, there's still no atmospheres. The Earth was just starting to cool off. But look out, at the edge, we have another cosmic collision taking place. And this was a very important cosmic collision. It happened again about 4.5 billion years. And it's the predominant theory on how our moon got formed, which is the moon is a fragment of the Earth. And eventually those fragments started to agglutinate and concentrate and form the moon, which is played a key role on life on our planet as well. It not only eventually when the oceans form, we produce the tides, that motion that really was also critical to the origin of life as we know it. Eventually, the Earth really cooled down, and this system, we have to note that really our planet was the first to have a natural moon. Mercury, Venus do not have moons, and the third planet did, which it was key because it was living in the habitability zone, and habitability zone is defined as the area where where water exists in the form of liquid. But comets played also a key role. We believe they were the messengers of not only that brought comets to, water, and I introduce you to Dino, I'm sorry.
It's really interesting. Earth is warm, and comets bring water to fill the oceans. We have all the ingredients for life as we know it. Water, heat, sunlight.
So those were three key ingredients, indeed. Basically the liquid water, organic material, and a source of heat. If you had that, life may evolve as we know. So comets played an important role in seeding life, bringing the amino acids that eventually form the proteins, and as well as bringing water during the bombardment period of our solar system. So let's now move forward in time. 65 million years ago, where the Earth suffered an amazing event took place that we call the KT mass extinction. So indeed, dinosaurs control our biosphere for over 180 million years. Our planet was a very different place. It was higher in oxygen. The temperatures also were higher. But something happened. That changed the balance of life in a split second. And if we look from our virtual spacecraft to the Earth, at that moment, 65 million years ago, we see what will happen, and Dino will tell us. So there were incredible tsunamis, over 1 kilometer in height, the waves. Global fires as the fragments of the target rock re-entered the Earth's atmosphere. Our planet became very opaque. It truly became like a Venus today. So the yellow line here depicts that limit. Cretaceous, the era of the dinosaurs. Tertiary, the mammals dominated. And it's important to note that over 50% of the species of these extinctions took place on the oceans, while 20% took here on the land-based species. This all got started by a science paper published in 1980 for a team from a team of investigators, father and son, Walter and Louis Alter is heading the team, in which they proposed that an asteroid was about 12 kilometers, 16 kilometers in diameter was the cause of the extinction of the dinosaurs due to an impact. And that changed the balance of life on our planet. The key piece of evidence that they had was iridium. Iridium is an element of the platinum family, and is found on Earth's crust, but in minute quantities. To have the large concentrations that they found, it had to be a connection with asteroids or comets, because that's where you have large concentrations of iridium. This became tremendously controversial. The paleontological community did not want to really concise that an asteroid would have killed off over 50% of the species 65 million years ago. There were craters on Mars, on the moon, but craters on Earth. We're talking 1980s. And the challenge was, where was the crater? Because the Alvarez team were not able to identify the location of the crater. So the scientific community responded by looking for the crater. There has been to date over 200 impact crater structures identified in our planet. And there is an interesting, if you could see the northern hemisphere, there is a few more craters than in the southern hemisphere, and that only represents really the amount of research, where the amount of research has been done, truly. The evidence were three: the iridium concentration, the iridium anomaly, shock wars, and tektites. Each of these red dots symbolizes the large concentrations of iridium. The shock wars is really a grain of sand that has been exposed to high pressures that deforms its crystal lattice. And the tektites, which are basically glass spheres that contain the composition of the target rock. Those had been found, but still the crater, we didn't know where it was. And I was working with a team of archaeologists in the Yucatan Peninsula looking at some of the Landsat data, and they came across a very interesting semicircle. They didn't know what it was. I immediately thought, circular impact crater. At that time, we formed a collaboration. Eventually, we found the geophysical data, and indeed, it was a large impact crater buried under a kilometer of rock that today is known as the Chicxulub impact. We then formed a team on trying to understand what were the mechanisms of the extinctions, and we found that the target rock was very rich in sulfur, and that played a key role to make the planet first very cold, and then eventually it warmed out. Since then, I led over 6 scientific expeditions, and we were able to identify more geological evidence to confirm that indeed Chicxulub was the KT impact. It's important to note, let Dino tell you about this.
That big space rock?
What do you think? So we're lucky to have the stars, the asteroid impact in the Yucatan Peninsula, and became descendants of mammals. But I just wanted to, just pause there a moment and conclude on why this type of research is important as well. There is a very strong correlation with planetary geology. What do we do in planetary geology? We go and study other planets to learn more about our own planet. And here you could see what we call the fluidized ejecta blankets, FEBs. And these FEBs are important. Why? Because they tell us that the target rock was very rich in volatiles to form this type of shapes that in many cases are formed like the petals of a flower. The Chicxulub impact crater is the best, which by the way is about 200 kilometers in diameter, so it's a large, large impact. Is the best preserved fluidized ejecta blanket that we have in our planet. So we are learning a lot from Chicxulub to take that knowledge base to other planets like Mars, and also try to identify localities where liquid water may have existed or still may be at. Thanks to Curiosity, we know Curiosity landed in the Gale crater. It landed in an impact crater that it has been confirmed it had fresh water. There was a lake in that crater. And it has a beautiful ejecta blanket, which is an FEB. It is really interesting because Curiosity now has confirmed liquid water in the subfloor of Mars. So that, in terms of exploration, is very, very important, because in the 2030s, we are preparing to send humans to Mars. This is happening now. We are building the rocket, the SLS, that will take us there, the capsule with collaboration with SpaceX and the private sector, and there will be 6 astronauts that will be traveling in the 2030s in your last lifetime. So I hope, I hope you take that into consideration when you follow your career path on the different type of world that we are all going to be living at in 10, 20, 30 years from now. And planetary science is an incredible instrument because discipline. It teaches us to think globally. When we look at a planet, we really need to always look at its global systems. I always like to share something that is not as well known as a direct application on why it's so important to go study and do research in other planets. And maybe I will ask you, I'll put the challenge. So how many of you know where the greenhouse effect was first identified? Okay. The greenhouse effect was first really identified on the planet Venus. It was things that we sent a probe. It was at the beginning of the video there that it went to Venus, that afterwards we took those measurements and did atmospheric modeling of it. And when that model was compared to Earth models, as you do in anything, any type of science, you compare, then it was realized that the greenhouse effect was taking place here on Earth. So that's a direct benefit of planetary exploration. And we really, as our NASA administrator always likes to say, we go there to know more about here. We invest on Earth, even though we explore the outer solar system. So with that, I want to thank you for your attention. I want to put the challenge in front of you to go boldly and go explore, go discover. That's what our species is meant to do. We are a space species that we are meant to be interplanetary and eventually an interstellar species. And that's the future and the challenge that you have in front of you. Thank you for your attention. The universe is waiting for you. Wow, no, please sit down.
I think we're going to be here a long time.
I have a lot of so, but just so you know, what you will be getting, hopefully, if you ask a question, is the Curiosity team member pin. Only if you're a team member of the Curiosity mission, the Mars Science Laboratory, which, by the way, is the most ambitious laboratory that has been sent outside our planet. It's an extraordinary set of innovation. Is incredible, and it's been functioning outstandingly well. So I think you'll be proud to be a member of the Curiosity team. But thank you for that question. My PhD, well, I basically had to work my way through school. I had to work full-time, many times go to undergraduate, graduate, part-time. So it took me a long time. I actually applied to be an astronaut several times. And I know the reason I didn't get selected was because I didn't have a PhD at the time. So it was truly important. I mean, and by the way, we are still doing selections every 2 years. We just selected, we had over 6,000 applicants, and we selected 12 astronauts or mission specialists. They don't become astronauts until they don't fly. And it was really great. It was very, very well balanced because 50% were women and 50% were men of the new selection. And those will be the astronauts that will be training the future, basically, human mission to Mars. So it's really exciting. But indeed, I ended up doing my PhD at the Netherlands. So I had a challenge to learn that language. It's not easy, at least enough to be able to write a portion of my thesis in dissertation in Dutch. But so it wasn't a straight path. And I had, when I first started the impact grading processes were not even being taught in geology. There weren't many universities that you could go to take planetary science. Still to this day, there are very few universities that you can get a PhD in planetary science. And so there were many, and there were many I didn't have, to a sense, role models to follow that sometimes could, which is very beneficial. I highly, highly recommend that you get a lot of mentors. And don't wait for them to ask you. You have to be proactive and go ask for a mentor. And you have to have mentors at different levels. You can have a mentor that is just your peer. And and you can have a mentor that is, somebody that you aim to be, that you would like to be. So always surround yourself with people that are smarter than you, and get that mentorship. Never be afraid to ask for help. Never, and ask the questions. There is no questions that are not important. So I had a lot of challenges in my PhD, and I basically didn't finish my PhD until, I was over 50 years old. So it took me a while. But like the little turtle between the races, I didn't give up. And I think that's the key. No matter what you do, if you believe in yourself, if you want to achieve that, and you do it for you, not because you want to have that title do it because you want to acquire the knowledge, because you want to share that knowledge to advance our human species, to benefit our community, our society, and our planet. Okay, any other?
So you were researching the crater and all that with the dinosaurs and such. What were some prominent findings from that research?
Excuse me, sorry.
So what were the prominent findings from that research? Well, let's see. It was a tremendous challenge. I wasn't well known in the impact community at all. And, sometimes to break into a new discipline, when we first identified, we knew there was an impact, and we submitted it to Science. Science took almost a year to review the paper. It was so controversial. It finally ended up they didn't want to publish it, even though we had the geophysical evidence, the data, the remote sensing that correlated, even the topography, altimetry, all. And eventually we submitted it to Nature, and Nature allowed us to publish it as a scientific correspondent, and they made us change the title to put a question mark. Possible location of the KT impact. So you have to be prepared for those challenges, that sometimes you're breaking into a discipline that doesn't welcome too many new thoughts or people, in that sense. It could be quite challenging. But and then we wanted to try to find out, okay, how the extinction took place, why it wasn't just kaboom, and even though the amount of energy that was emitted, it was 10 to the 23 ergs. It would probably mean something to Dr. Professor Diaz, but it's like all the nuclear arsenal in the world will go off and still it wouldn't go to the 10 to the 23 ergs. It's an amazing amount of energy emitted. So, so with that, we wanted to try to understand, okay, what role did the target rock play? What were the mechanisms in place? And one of the things that we did and we published is I briefly mentioned it, that the target rock was very rich in sulfur, and sulfur played a key role because when you mix some, target rock, which is a carbonaceous, it was at the time the Yucatan Peninsula had about 100-meter ocean, a shallow ocean, but it made a lethal combination of chemistry. It injected into our atmospheres a tremendous amount, tons and tons of sulfuric acid that eventually it, precipitated a sulfuric rain. And all this happened in a millisecond. And you can see this recorded in the geological record. I eventually, my PhD dissertation was, I discovered a new outcrop. I got to even name the formation and all that because it is the best preserved record of the first seconds, hours, minutes, and months after the impact. And it's astonishing. You see it. This is a location in Belize. So we were about 350 kilometers from the impact, and we were able to do a radial study, basically a distance from the impact, and see how the deposits had been changed. And then we were able to take the geological, geochemistry, and paleomagnetic data and put it in our models. And it really, it really helped us understand, that process, so that if it happens again, not if, when it happens again, unfortunately, is I didn't tell you the whole story about Osiris-Rex, but the whole reason that Osiris-Rex is going to Bennu is because Bennu has a possibility of a trajectory of impact with our planet in about 200 years. So it's going to happen. We will have another Chicxulub unless we truly become an intelligent species and really learn how to deter that. And we are working on it. We are working on not getting an asteroid and not go and explode it because you make the problem much worse. That's not intelligent. But yes, go and deter, deviate its orbit by even implanting ionic, turbochargers, basically motors, and be able to deviate a little bit its orbit. There is something that the Osiris-Rex mission is measuring, is something that's called the Yarkovsky effect. And it's very interesting because Bennu is a very, very, very dark. It's so dark, it's so black that light doesn't, its albedo is almost zero. Light doesn't get reflected. Is incredible, very rich, carbonaceous, very rich in carbon, and we're going there also because it's an incredibly interesting scientific target that we've never been to before. And what the Yarkovsky effect does is when the sunlight gets into reflects into the asteroid, that heat is enough to produce a deviation in the asteroid or in Venus orbit. And we want to go and understand how the orbit of Venus is changing. So we're learning a lot, how to prevent this type of type of episodes. I mean, not to prevent, but when it happens, how to be able to defend ourselves. And we, literally, in NASA, we have an officer that's called Planetary Defender. It's the Office of Planetary Defense, literally. We work with FEMA and the other space agencies around the world to develop, develop strategies, because even just not long ago, we had an asteroid that traveled between, it hit Antarctica, but it took us completely by surprise. Hopefully, it came from the sun, so we couldn't see it. And you probably all remember the episode that happened in Russia not long ago, a few years now back, but also it was quite scary for many people, and we didn't even knew that was in our radar. So there is a lot yet to be. We are cataloging, we have cataloged now more than 90% of the 1 kilometer plus asteroids, but the small ones that could still be quite devastating are yet to be known. So I'm sorry for a long answer, but the aspect of the sulfur and how that affected and the mechanism of extinction was also part of the contribution of our team.
Another question for the students? Yes, over here.
Okay, so the question is, how did I decide to go into space science? It all started in the roof of my house in Argentina. I used to go up there with my dog and look at the stars, and I was just amazed. I wanted to understand more. I mean, that was a passion that I had, but of course, there wasn't a discipline. I didn't know it was called space science, and it didn't exist at that time. I started as an aerospace engineer. And then it was when I saw during the Viking era, July 20th of 1976, I had just graduated, but it was just, I was amazed looking at the landscape of Mars. It looked like Earth. It was incredible. And how could that be? What was happening there? What processes brought about the differences and the similarities? And I was really captured by those images, by that information that was coming down. And there was an emerging discipline that was planetary science, so I changed my degree to go into what I eventually became planetary geologist. Thank you for your answer.
How about back here?
Who were my main role models? Well, my heroes were my parents. And would you please? And I really, I consider myself very fortunate because I was privileged to be at the Jet Propulsion Laboratory where there were people, extraordinary scientists. There still are, but I was fortunate to get to know Carl Sagan. The cosmos. I don't know how many of you have heard of Carl Sagan, but he was an extraordinary scientist and really a communicator. And he just, was contagious. You had to love planetary exploration after meeting him. There was no question about that. And I also met Eugene Shoemaker. He was part also my mentor, and he installed in me the interest and the passion for impact cratering. You know, Shoemaker was the father of impact cratering. He did his PhD thesis on the Virgin crater. At that time, it was called the Flagstaff, near Flagstaff in Arizona, and they thought that it was due to volcanic, and indeed Eugene was the one in his PhD that proved that it was of impact origin, and he was the first to start looking for the indicators and like shock quartz and some of the ones that we talked about. So there were many in that sense, even though there weren't many women that looked like me or spoke like me or anything like that. It eventually became a lot more diverse. But at the same time, there was that environment, and there still is, that you really, if you have a good idea, that's what it waits out, is the science, is the idea, the innovation that you can bring to the table. So even they put up with me that even I look different and I spoke different ways or something. But so in that sense, it's been very enriching and continues to be. I just don't see myself retiring of any time because I love what I do. And it's just hard. When you have a space exploration in your blood, you never want to leave it. It's really that amazing of a career. But thanks for your question.
So we're going to do one more question, and then we'll have lots of...
So the mission to Mars, but the human mission to Mars, we've been exploring Mars now for over 40 years with robotic missions. And the challenge was put to us by President Obama in 2010, where he challenged NASA to say, okay, by the decade of 2030, there should be a human mission to Mars. So we've been steadily working on developing new launch vehicles. So the launch vehicle, it is existing. It exists. It's been tested. We have formed partnerships with the private sector, which we are very happy is taking place because we need that partnership. Space has to be something done not only as a planetary with multiple nations involved, but with multiple sectors, and the private sector can play, and it is playing a key role, like a SpaceX, like Blue Origin. So it would take, with current technology, about 8 months for the humans to get to Mars. And the launch window, the planetary launch window, which is very important, we cannot just launch any time. Celestial mechanics dictates when. And there is a planetary launch window every 2 years. So all our missions that we are planning are obviously a round trip. And we are very conscious of making our astronauts that will go, as safe as possible. That's priority number one for NASA and I think all the space agencies. It is a challenge. There are technologies and innovations yet to be made, definitely. Not long ago, you probably heard SpaceX had a launch failure. We were actually the next launch pad. I was there in KSC when the explosion happened. Just a few days we were due to launch OSIRIS-REx on September 8th. So it just happened like September 5th or something. But and now they are coming, we're learning, they're learning, we're working. We're very much partners in this journey to Mars, in this exploration. NASA is also providing substantial funding to SpaceX at the tune of $400 million per year. So it is, it is a big investment, but at the same time, the amount of innovation and technology that comes out is extraordinary. You just have to think over almost 70% of our everyday life, of the things that we use every day, come from are derivatives from space exploration, space technologies. And I think sometimes we don't recognize that, and it is very important. So that innovation, that technology is a new era of exploration on how we're going to go about going to another planetary body. This is not going to the moon. This is going to another planet. It's hard to think about that, but what you saw probably in The Martian, I mean, that was science fiction, but it's really becoming science fact. This will happen in your lifetime. Is an extraordinary event. I mean, we are evolving as a human species to truly become a space species. And that 2030 decade, it will be an incredible one. But before then, in the 2020s, we're going to do a deep mission that will train the technology and the techniques, the strategies. We will, with humans, we will get partway to Mars and then come back. At the same time, in the 2020s, we're launching another robotic rover to go to Mars, that it will have a lot of the technology needed, for example, to extract water, to measure better the radiation, how to make a habitat more amenable to humans on Mars. And so there is a lot to do, a lot to learn, but it's an extraordinary challenge, and I hope you join us. Thanks for your question.